All right, so I'm going to go through all the test questions from Form 1. Compare this to your test, so hopefully we can make sure you understand how to do all the questions. So question number 1, first you're going to isolate this 1/2 exponent. So I need to add 6 to both sides. Then I have 3g plus 1, all raised to the 1/2 power, equals 10. All right, now, in order to get rid of the 1/2 power, we're going to square it. So I have 3g plus 1 equals 100. Now I'll just solve for g. Minus 1. So 3g equals 99. Divided by 3. G equals 33. Number 2, we need to isolate the cubed root. So I'm going to minus 6 from both sides. So I can write the cubed root as q minus 4 to the 1/3 power. 9 minus 6 is 3. So to get rid of the cubed root, we're going to cube everything. So I have q minus 4 equals 3 cubed is 27. 3 times 3 times 3. Add 4. Q equals 32. All right. Number 3. Excuse me. The vertical asymptote. In order to find the vertical asymptote, you need to set the denominator equal to 0. So x plus 7 equals 0 minus 7, x equals negative 7. If y varies inversely with x, that means y is equal to some value k divided by x. So if I know y is 12 when x is negative 2, then I know 12 equals k divided by negative 2. To find k, we multiply by negative 2. Negative 24 equals k. Now I know that I can use the formula y equals negative 24 over x and find y when x is 4. So y equals negative 24 over 4. So y equals negative 6. All right. If I vary directly, then I can use the equation y equals k times x. So if this is the pair that goes together, 8 equals k times 2. To get rid of the 2, we divide. So I know k equals 4. So now I can use y equals 4x to find y when x is 6. So y equals 4 times 6. So y equals 24. Number 6. When we're solving a system of a linear and a quadratic equation, first you know that this y is the same as this y, right? So I have negative x plus 1 equals x squared plus 5x plus 6. I have an x squared, so I have a quadratic. And the only way to solve the quadratic is to get it to equal 0 so that you can factor it. So we're going to add x. So 1 equals x squared plus 6x plus 6 minus the 1. 0 equals x squared plus 6x plus 5. Now I need two numbers that will multiply to 5 and add to 6. That's 5 and 1. So 0 equals x plus 5, x plus 1. So when I solve those for 0, I get x equals negative 5 and x equals negative 1. Now, a lot of you stop there. But when you're finding the solution of a system, you're really finding the ordered pair or the point that they would cross each other. So in order to have an ordered pair, I need to take these x values and find their y's. So I'm going to go back to my original equation, y equals negative x plus 1. I'm going to use x as negative 5, so y equals negative 5 plus 1. Negative 5 is positive 5, so y equals 6. So one of my ordered pairs is negative 5, 6. Do the same thing with negative 1. So y equals negative x plus 1. So y equals negative 1 plus 1. Negative of negative 1 is positive 1 plus 1 is 2. So my other ordered pair is negative 1, 2. That's the answer. All right. In order to solve log base 7 of 2 equals x, the way I taught you how to do this was to first make it exponential form. So you have 7 to the x power equals 2. Then you need to look at the bases and see if you can get the bases to be the same. I can't make 7 and 2 the same base at all. So then I told you to take the log of both sides. Because then you can take the exponent and bring it down in front. So you have x times the log of 7 equals the log of 2. Divide by log of 7. So x equals, so log of 2 divided by log of 7. I closed my calculator, hang on. Is 0.356, is rounded to 3 decimals. All right, number 8. We cannot solve a rational equation if our denominators are not the same first because we have addition. So first I'm going to factor this denominator. I can say is x minus 5, x minus 2. Okay, so now I need to multiply the other fractions by something so they'll have the same denominator. So if I multiply this by x minus 5, then I'll have the same denominator. If I multiply this by x minus 5, then all of my denominators would be r minus 5 and r minus 2. Oh, I didn't mean to change the r to x. Hang on. R. Okay, but if I do that to the bottom, I have to do it to the top. And this middle one doesn't multiply by anything because I didn't multiply it. That is the one I'm trying to match. So 1 times r minus 5 is r minus 5 over r minus 5, r minus 2, plus 1 over r minus 5, r minus 2 equals 6 times r is 6r, 6 times negative 5 minus 30 over r minus 2, r minus 5, whichever order you write that in. Now that I have all the same denominators, when there's an equal sign, we said that you can get rid of the denominator and solve the numerator. So r minus 5, or r minus 5 plus 1 equals 6r minus 30. So negative 5 plus 1 is negative 4. So now we're just going to solve for r. So if I minus r, negative 4 equals 5r minus 30, add 30. So 5r equals 26, divide by 5. So r equals 26 over 5. Number 9. If I have the x is squared, and that's what's happening here, right? And all in all, really, I have some other stuff going on, but x is squared. So when I raise this to the 1/2 power or take the square root, 16 can be 4 or negative 4. So I have x minus 5 equals 4 and x minus 5 equals negative 4. So we're going to add 5. So x equals 9. And the other answer, x equals 1. All right, last. If we're going to simplify these, I always told you that if you have multiplication, you're not really going to multiply anything out. You're just going to rewrite everything as one large fraction. So on the numerator, I have x minus 8, 4x plus 10, or x plus 10. On the denominator, I have x plus 6, x minus 8, and x plus 10. Now take out anything that's the same on the top and bottom. So x plus 10s can come out, x minus 8s can come out. And all you have left is 4x on top and x plus 6 on bottom. That's it.